Hello everyone, this is the third video in the polar coordinate and graphs section. We're going to talk about graphing and we're going to introduce some of the basic polar graphs. We're going to see things like right here, this is a four-petaled rose, that's what they call this. This is a limacon, which you'll see a name for that later. And then this is a spiral, which kind of looks like a spiral, so we're good. But we're going to talk about all these different ones and how you can draw some of these graphs by hand and how you can also do them on your graphing calculator. So you want to be sure you have your graphing calculator handy so we can go over it together. The first thing I want to talk about are some very basic graphs. Remember that polar coordinates come in r and then theta. So to graph just a single point, this is just a single point on a graph, you would have the angle from 0 degrees, or 0 radians, and then you would go to that angle and then out from the center in the same direction for the radius. But what if you had something like this? What if you had the radius is equal to 2? Well, that means that no matter what the angle measure, the radius is always 2. So if I'm at 0 and I go out 2, if I'm at 90 and I go out 2, if I'm at pi and go out 2, if I'm at 3 pi over 2 and go out 2, and you can see that if I pick every single point in between those, it becomes a circle. So r equals 2 is just going to be a circle with a radius of 2. R equals 1.5 would also be a circle with a radius of 1.5. So it's just a circle. So no angles, just the radius is always 2. So in the same way, on this second example, theta is equal to pi over 6. That means that it doesn't have any measure. In other words, it's not 1 out from the center, it's not 2 out from the center, or it could be all of them. So if this is still 0 radians. 0 radians. I don't know why it won't write. 0, there we go. Then this first point right here, this is pi over 6. Well, if I'm at 0, right, my angle is still pi over 6. If I'm at -1, it's still pi over 6. If I'm at -2, -3, -4, -5, +1, +2, +3, and you can see that all the points in between are going to be a line. So this is a line that goes through the angle pi over 6. So if, for instance, I had theta is equal to pi over 2, then that would be all of these points. Let me change color. Pi over 2 would be this line. If I had theta equals 2 pi over 3, then I go to find 2 pi over 3, which is this one right here, and draw a line. So it would have the r of 0, r of -1, -2, -3, the r of 1, 2, 3, 4, and so these are just lines. Okay, on the next couple of slides, I just want you to take a look at some of the types of basic polar graphs. The first one here is a cardioid, and it looks a little bit like a heart. You can see that it's got a little bit of a dimple here. This is a cardioid that is more like this one. If you look here, is cosine, and it's symmetric with the x-axis. This is sine, and it's symmetric with the y-axis. Okay, so we've got horizontal and vertical, and you can see the form that the equation takes. This is a limacon, it's French, and that's why that's on there. And this is a looped limacon. This is a dimpled limacon, and this is a convex limacon. In other words, it doesn't have any kind of indentation in it. It's not quite a circle, though. See how straight it is here. And then here are 3 others. These are rose curves. You've got 4 petals, and notice that it's symmetric with the x-axis and the y. It's right on the axes. This one's not. It's a little bit off. This is 3. This one has, how many is that? 1, 2, 3, 1, 2, 3, 8. And this one's even more than that. 12, probably. Notice that I said 8, and this is a 4 here. Okay, so, and these are all cosine. This is a lemniscate, which looks like an infinity, and this shows the equation for that. And then these are your spirals. This is an Archimedes spiral, which we saw on the very first screen. Here's a hyperbolic spiral, logarithmic spiral, and a parabolic spiral. All kinds of interesting spirals. Okay, here's an example that I'd like for you to follow along if you have your graphing calculator. To graph these kinds of graphs on a calculator, you have to put them in polar mode. And so this screen over here is when you hit the mode button, and then come down here, it's in radians. Notice it's not degrees, it's in radians. And then change it from function to polar. And that's the only thing you check in the mode button. Over here, if you go to second zoom, there's the format button up there, and that's where you get this screen right here. So you're going to change it from rectangular coordinates to polar coordinates, and you're going to do that if you're going to use trace to kind of see what the points are like around the graph that you're going to do. So this is the first example that I want you to graph. Once you put it in these modes, instead of y equals, it's going to look like this screen. It's going to be r equals. And you're going to put in 6 sine 2 theta. You're going to hit zoom 6 or zoom standard, and it's going to change the window to these coordinates right here. Zoom standard, it lists here what that looks like. And then when you go to graph it, it's going to look like this. So you've got a rose with 4 petals that don't go through the either axis here. Okay, so you have this. If you do zoom square, like zoom 5, for z square, then that's going to make it look a little closer to the actual shape of it. And so one of the things that we're going to do is we're going to graph several of these so that you can kind of play with them and see how you manipulate the equation is going to change the number of petals you have, whether it's symmetric about the x and the y axis. But I do want you to try this, and especially putting it in polar mode and putting them in the polar coordinates. And then if you'll do second, hit trace and trace along the outside of this graph and see the coordinates that appear at the bottom so that you can see that they're in r theta. If you put them in rectangular coordinates, you're going to get xy coordinates, just like you would on a regular xy Cartesian plane. So I would like for you to try this before you get to class so that it won't seem such a big jump or leap to do that. Okay, so here's an example of how you would plot this by hand. And so what I would like for you to do is, since you have your graphing calculator, I would like you to go to mode and change from radians to degrees, because you notice here that in my table I have degrees and not radians. Okay, then I want you to make sure that you've gone down to function and changed it to polar mode. Go to y equals and put the equation 5, and it should say r equals when you're there, r1, 5 sine, and in the parentheses put 3 and then hit the x button. Notice that that's a theta. Okay, and then I want you to graph it, and you can do zoom. I'm going to do zoom 5 to do zoom square. So when I did that the first time, I couldn't get the graph to appear. And so what I did is a zoom 6 and then a zoom 5, and you should have a 3-petaled rose. The other thing I noticed that when I hit second graph and went to the table, it had some very strange things, so I wanted to set that up properly. So what you need to do is go to second window, which is table set, and I put the table start at 0. So table start at 0. I think TBLST. And then I did by 15. And the reason I did that was because this goes 0, 15, 30, 45. And so I wanted the table to go ahead and read out my values. So I do second table, and then I'm going to write these values in. I'm not going to have enough room here, but that's what I want you to do, is stop the video and write these values down. Okay, so now we have these values, and so we're going to graph them. So at 0, 0, right, 0 degrees, 0 out. At 15, I'm going to go out 3.5. 1, 2, 3.5. At 30, I'm going to go 5. So that's here. And at 45, I'm going to do 3.5. And if you'll notice, that's my first petal. Because at 60, I'm back at 0. At 75, I'm at negative 3.5. So that means at 75, I'm going to head back in the opposite direction. So at 75, this goes, starting at 0, here's 75, 1, 2, 3.5. At 90, I'm at negative 5, so that's here. And at 105, I'm at negative 3.5. So I go in the opposite direction, and notice the symmetry. So now I have another petal. And then the last petal starts back at 0. At 135, it's positive 3.5. So I go 1, 2, 3.5. At 150, it's at 5. At 165, it's at 3.5. And I have my third petal. All right, and at 180, I'm back to 0. So that's how you would see, and notice that there's a lot of symmetry. Symmetry is hugely important in most geometric concepts, but I want you to see that it's symmetric about the y-axis. The three rows, the 3 petal rows is symmetric about the y-axis. All right, so in class, that's what we're going to do, is we're going to graph some of these by hand. We're going to use our calculator as a tool. So when I see you again, we'll be ready to go. See you in class.